So quadratic inequalities are one of those key skills. It's a basic skill, but it's going to come up in pretty much every topic that's coming your way. And it's really important that you get a good grasp on it so that you don't unnecessarily lose marks. So what are we talking about when we talk about such a thing as an quadratic inequality? Okay, linear inequalities, you've done lots of those before, you know how they work. Quadratic inequality is a little bit of a different beast. You remember when we have an equation, we are solving for roots. So we're saying, where does our quadratic equal 0? So where is it crossing that x-axis? And then we solve for those values of x. When we're talking about an inequality, it's a different kind of relationship because we're not looking for where we equal to certain values. We're looking for where we're in relationship to different values. And the way that we do this with a quadratic is that we actually relate it to 0. If we draw ourselves a simple quadratic, here's just an x-axis, because it doesn't really matter where it is on the y, okay? It's all about that x-axis. So here's our quadratic. So when we solve an equation, we are solving for these two values of x. Where does our quadratic equal 0? Where does it cross that x-axis? So these are the solutions or the roots to the quadratic equals 0. Okay, but we also have this sort of above and below our x-axis thing going on. And that's where our inequalities come in to power. Okay, so in this zone here, okay, so we've got this piece of the graph on the right, we've got this piece of the graph on the left, but both of these pieces are above the x-axis, okay? So in this case, we would say that our quadratic is above the x-axis, therefore it is greater than 0, because it equals 0 here. So when we move above the x-axis, our quadratic is bigger than 0. When we below the x-axis, so any value here on our y-axis is a negative value. So our quadratic is less than 0. So for any x values that give us these values above, okay, so an x value, let me get a blue back again, a different blue. Okay, so all of the, whoa, sorry, not an eraser. We want a blue pen. Hopefully, yeah, okay, right. So any x value along here, all of these values, and remember our graph goes on and on and on and on and on. So all of these x values are going to give positive values. So they would be quadratic greater than 0. Same thing on this side. All of these x values, if we plug them into the quadratic, ax squared plus bx plus c, we would get out a value that is positive. So our quadratic would be bigger than 0. If we take our x values here, if we plug these x values in to our ax squared plus bx plus c, the value that comes out is going to be a negative value because our quadratic is less than 0. So now we've got a very colorful x-axis. Okay, we can see different zones on that x-axis. So what that brings us out is this beautiful relationship. Okay, if in the case where we have a happy quadratic, if we have a sad quadratic, it's different. But of course, if you have a sad quadratic, you can just shift everybody else on the other side. Okay, so when you have happy quadratic, is greater than 0. See, we've got two zones here that we colored in blue. Okay, so let us put that little red one back. And we shall give our red ones on, let's call this one A and this one B. So the values of x where we equaled 0 when we solve that equation. So when we have a happy quadratic greater than 0, any x value that is less than A, okay, all of these blue ones here, those would give us happy quadratic. If we have a happy quadratic that is greater than 0, we also have another region over here where x is greater than b. because all of these values will give us positive output. So we have greater than 0. Okay, so we have here 2 zones for answers. For a happy quadratic is greater than 0. If we look at the flip side of that coin, if we have happy quadratic is less than 0, well, here we only had the one zone. See, all our greens are together here in the middle between A and B. So A is less than X, which is less than B. This is only one zone. And that is then a crucial understanding that the answers are going to get a whole lot more fun than when we just solve for our linear inequality or for when we solve for a quadratic equals 0. We've got a whole lot of different things going on here depending on what relationship is that we're looking for. So how do we actually go about doing this? This is a case where we have a whole sort of series of steps to follow. Okay, so one thing before we leave here, I just want to highlight, we've called these solutions, we've called them roots, okay? We're also going to call them now critical values. Why are they critical? It's because it's where the relationship changes. Okay, so we go from greater than 0 to less than 0, and it changes at equals 0. So the equal 0 is the critical value. Okay, it's also the solution, it's also the root. But it's a critical value in the relationship because that's where it tells us, oh, no, we're on the other side now. We were above, we're below, we were below, and we were above. Okay, so we're changing at that critical value. So now we're ready for those steps. So steps to solve a quadratic inequality. Now, these are steps that you are going to become very familiar with because every time you see quadratic, so every time you see x squared and you see an inequality in the same little statement, you are going to follow these steps. This is how you do a quadratic inequality. Okay, so first one. You want to have happy quadratic related to 0. And in some cases, you'll be doing things before you get to this stage, and it's actually a mark for having a happy quadratic related to 0. So it's a crucial part of this step because as you saw on that previous one, everything is about this, are we above or below 0? So we have to have that relationship to 0. In the same way that if we want to solve, we would have to have equal 0. If we want to do an inequality, we have to have related to 0 before we do anything else. Our next step, we're actually going to give them 3 words in English for critical values. Okay, because the next thing you're going to do is you're going to evaporate that inequality and turn it into an equal sign. So you need to give a justification. It's not that I just don't know what to do with this inequality. It's because I know what to do. I know that in order to get my critical values, I have to have equals. I have to have an equation. That's the only way I can solve a quadratic. Therefore, for my critical values, I'm doing this next thing. And the next thing, of course, as you've guessed, is to solve quadratic. Quadratic equals 0. So you get your answers, x equals A, x equals B. Then what do? You draw a mini sketch because you want to help yourself in your brain get clear on, where's A, where's B, what's above, what's below, what am I actually looking for? Okay, so you need a mini sketch, just little, with your zones of interest marked. And then only after that, your last step here is to state the answer to the inequality. So that very last thing that you're going to do is, again, looking back at that original question and stating your final answer. So whenever you see quadratic, whenever you see an x squared and an inequality in the same statement, you're going to work through all of these. Happy quadratic related to 0, state for critical values, solve quadratic equals 0, do a mini sketch with your zones of interest, and then state the answer to the inequality. 5 steps. Okay, so you can work through them all. And now we're going to work through some examples so you can actually see these 5 steps in action. Start off with something simple. So we've got x squared plus x minus 2 greater than 0. So there we go. There's step 1. We have a happy quadratic and it's related to 0. So the next thing we're going to do is say for critical values. Because after that, we're going to change that inequality. We cannot, sure, we can factorize the left-hand side, but we can't get an answer unless we have an equals 0. Because to solve a quadratic, you must have equals 0. So we would then say x squared plus x minus 2 equals 0. Now we can factorize x and x. Factors of 2 that subtract to give 1 is 2 and 1. Big one is positive. So we have x equals minus 2 and we have x equals 1. So now we can see that we have done step 2 for critical values and we've done step 3, solve happy quadratic equals 0. Then comes our mini sketch. So pencil, x-axis, quadratic, minus 2 and 1. Now we also want to mark on this mini sketch which are the zones that we want. We've got happy quadratic is bigger than 0, so we want the 2 zones that are above the x-axis. So that then was step 4. And our last step, our final step, is stating the answer to that inequality. So everything smaller than minus 2, so x is less than minus 2, x is greater than 1. Okay, and somehow I'm not managing to speak and write at the same time today. X is less than minus 2, x is greater than 1. So we have 2 answers for this inequality because we have 2 zones that give us the greater than 0. And that then is our step 5, that final solution, that final answer. Let's do another one, something slightly different. Let's go for x squared plus 5x plus 6 less than or equal to 0. Okay, so again, the question is lovely. It's done our step 1 for us. It has given us happy quadratic related to 0. So, same second step for critical values. Change to 0. Factorize. We're not ever going to use a formula if we can factorize. Factors of 6 that add to give us 5, that's a 3 and a 2, plus, both plus, so everything's plus. Plus 3x plus 5x plus 5. 3x plus 2x gives us 5x. So x equals minus 3, x equals minus 2, and there we can see them again. There's step 2, there's step 3. Next one, pick up your pencil, mini sketch, x, happy quadratic, minus 3, minus 2. Which zone do we want? Back to the original quadratic, quadratic less than or equal to 0. So we want this, but in the middle, only one answer in this case. So now we would have minus 3 less than or equal to x less than or equal to minus 2. So there's our step 4, the mini sketch. Step 5, the final answer. And there's another thing for you to note. See, in this answer, we had a less than and we had a greater than. Here, we've got the or equals to. That's because it always links to the question. Okay, in this first question, we had greater than 0. The equal 0 was not included. In this question here, we had less than or equals to 0. So the equal 0, the critical value, is included. So therefore, it must be included in our answer. So the style of inequality that we use in our answer must always match the style of inequality that is used in the question. Whether or not we include that critical value with the equals or not depends on whether it is included in the original question. Are we happy? Okay, so then let's do a few more questions. (4x squared greater than or equal to 10x plus 6). So now, of course, things are getting more interesting. Okay, we do not have happy quadratic related to 0. We have quadratic, got an x squared. We got a relationship sign, we got an inequality, not an equal. So let's get it all on one side for the happy quadratic related to 0. So 4x squared minus 10x minus 6 greater than or equal to 0. But all of these are even numbers, which means we can actually make life a lot easier. Remember, we can divide them all by 2. So 2x squared minus 5x minus 3 greater than or equal to 0. Now we've got a nice, simple, happy quadratic related to 0. It is only now that we go and we say for critical values. Then we change to equal 0. So 2x squared minus 5x minus 3 equals 0. 2 and 3 are both prime. So factorization becomes a whole lot simpler. They each only got one option. So 2x and x, so a 3 and a 1, or a 1 and a 3. We're subtracting to make a 5. So a 2 and a 3 makes a 6, and a 1 then can subtract for a 5. Different signs. Bigger one, negative. So there's a negative and there's a positive, and we can check. Minus 6x plus x gives us minus 5x. So we get x equals minus a half, and we get x equals 3. There are our 2 critical values. So again, we've got step 1, quadratic related to 0. Step 2, for critical values. Step 3, solution of equation equals 0. Quadratic equals 0. We can solve that equation. Next one, minus a half and 3. We are looking for quadratic bigger than 0. So we're looking for those 2. So we've got 2 answers. So we have x is less than or equals to, matching the question, minus a half. X is greater than or equal to 3. So there is our last 2 steps. Step 4, our mini sketch. Step 5, our final answer. We should have time for another question. So let us try. 11x is less than 4 minus 3x squared. So we've got that same thing. We might have a linear x on the left-hand side, but on the right-hand side, we've got a quadratic, we've got an x squared. We've got an inequality, we don't have an equals. So therefore, we are dealing with a quadratic inequality. So this could creep up at any stage in part of a longer question. It's not something that you'll always just start with from the beginning. You could be doing this, that, something else, and then, oh, here's my quadratic inequality. So you've got to be good at spotting them, because as soon as you see them, no matter what you've done already, you need to switch into this mode so that you can solve your quadratic inequality properly. So one thing we've got here that's different, we've got terms on both sides. We've got an unhappy quadratic, okay, minus a 3x squared. And our sketch is a nice big smiley face, so it's much nicer to work with that happy quadratic. So let's bring them across. 3x squared plus 11x minus 4 less than 0. Okay, 3, 11, and 4, we can't simplify those. So we are now at that point of having our happy quadratic related to 0. We can then go straight to our 4 critical values. And we're going to have 3x squared plus 11x minus 4 equals 0. Because we're just looking for those points on the x-axis where our relationship is changing, okay, our critical values. 3 is prime, so it's an easy 3x and x equals 0. Now we've got a 4, we've got 2s, we've got 1s, we've got 4s. What are we playing with? Okay, we're making an 11. Sounds like we might need a 12 there. So 3 times 4 is going to give us a 12, minus a 1 will give us 11. Different signs, bigger one positive, so 3 times 4 is positive, minus. So minus x plus 12x gives us plus 11x. Never forgetting our equal 0 because we're solving this quadratic. So now we have x equals 1/3 and we have x equals minus 4. So again, we've had our step 2, our statement of intent, and we've had step 3, solving that equation for the critical values. Then comes our mini sketch, minus 4 and 1/3. What are we looking for? We are looking for happy quadratic is less than 0. So we want the zone in the middle. So we're having only one zone for this answer. So it is minus 4. Check your inequality, it's a plain one. So minus 4 is less than x, which is less than 1/3. Those critical values of equals are not included in this answer. So then we have clearly step 4, our mini sketch, and step 5, our final answer to the inequality. So if we just flick back a bit, quadratic inequalities are all about that relationship with that x-axis. Am I above? Am I quadratic over 0? Or am I below quadratic less than 0? Okay, we want to work through a set steps of 5 stages of this calculation. We relate that happy quadratic to 0. We state the reason why we're changing it to an equals. Okay, it's for calculation of those critical values. Then we change it and we solve it to get the critical values. We mini sketch and we figure out which zone it is that we want, depending on that original inequality that we're working with. And then we can state our answer to the inequality. So if you're working with a question where you are given that straightforward related to 0, it's cool. You can carry on and you can work through those 5 steps and you can give your final answer. If you're given a more interesting question, or if you bump into this during a longer calculation, then you still got to get to that point of happy quadratic related to 0 first, before you step through your critical values and you work through to your final answer. So well worth taking the time to make sure that you are absolutely, completely happy with quadratic inequalities, because as I said, they are going to come up in all sorts of different topics. And it's very important that you've got a handle on them, as they're quite a key skill. And you don't want that to cause you problems in other things.